Welcome to ClickMyProject.com. Let me discuss about the project Joint Subcarrier and Antenna State Selection for Cognitive Heterogeneous Networks with Reconfigurable Antennas. Let me discuss about the abstract of the project. Selection of reconfigurable antenna are capable of dynamically reshaping their radiation patterns in wireless link. Selecting an optimal antenna state for communication is essential and depends on the availability of full channel state information for all the available antenna states by different radiation pattern can maximize the received signal strength. Here, improvement of overall network capacity by employing the RA in multi-user orthogonal frequency division multiple access cognitive heterogeneous networks. In cognitive HetNets, secondary user is allowed to share with the primary user under the certain condition where the interference level caused by the primary user are limited below the predefined threshold. For solving the interference constraint problem, secondary user performs power control mechanism which limits the transmission power and also reduce the performance. Secondary user affected by more interference due to the large number of users. By proposing an efficient interference mitigation algorithm and resource allocation techniques, reduce the performance level of the network. Here RA technology implemented at every SUs in order to improve the received signal strength among SUs where resource allocation achieved based on the selection of radiation pattern. These techniques also provided the limitation of mutual interference between secondary and primary user. Proposed game theoretical approach for selecting joint subcarrier and RA antenna state at each SU which maximize the overall network capacity when causing the interference in the primary network. Finally, compare the performance with the scenario of conventional omnidirectional antennas and proposed approach here achieved maximum capacity by selection of best RA state and subcarriers for each SU. Let me discuss about the flow diagram for our process. Initially, the system model has been designed. In this, our proposed model consists of one primary base station and multiple secondary base stations in which PUs and SUs are located randomly. Here, SUs are equipped with RAs, which having the capability of choosing an antenna state among available possible state. Omnidirectional antennas are mounted for the PUs, PBS and SBS, whereas SUs uses the RA within the game structure. System also used orthogonal frequency division multiplexing approach, where subcarriers are assigned for each SU. The capacity of user at every subcarrier has been estimated, where considered interference caused by the received signal from jth SU and the kth subcarrier and the transmit power and also channel gains are estimated. In the power control, that is transmit power constraint of SU, the secondary user should maintain the interference level at the primary receiver must less than the predetermined value. This problem solved when SU transmit signal within a transmit power of PVA. And also interference power from the with antenna state information. Transmit power of SU requires only the knowledge of the channel variance. Next, we have to design the reconfigurable antenna with various pointing direction based on the antenna state selection algorithm. In the antenna state selection algorithm, APSS, FPSS approach are proposed. In APSS approach, before the game starts, SU selects set of antenna states based on location information. In FPSS approach, for all SUs, fixed state selection is assumed to be the same. The RA at the SU located antenna state pointing direction depending on the beam width. Total number of antenna state is 8 based on the adaptive beam width is 45 degree. The complexity of the subcarrier will be increases when the number of states increases. To reduce the complexity, the SU selects candidate antenna state among those fixed direction by implementing the game algorithm. In the joint subcarrier allocation and antenna state allocation algorithm are proposed. Initially, omnidirectional antenna assigned for all players, and selection of subcarriers are performed based on the highest capacity values. Whereas, if RA is having multiple antenna antenna states, and these are assigned for all players. Then all players receive the reports from all subcarriers for each antenna. Here the player selects best subcarrier based on the every antenna states where the capacity is estimated by the sum capacity of the selected subcarriers for each antenna state. After computing the utility of each state, the player select the one that has the highest payoff. Next, in the performance analysis, the overall capacity estimated under the implementation of both RS and BES algorithm, mean capacity difference obtained for varying the case 2s and from 6s by increasing the number of SUs, increasing in the capacity. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right-click the file and run for executing this process. And in this process, we have performed both the algorithm, that is RS and BS algorithm. These two algorithms for joint subcarrier allocation and also antenna state allocation process. Here we implemented APSS and also FPSS approach for performing antenna state selection algorithm. Here we obtain the result. This is the CDF response versus various capacity level between RS, BS and also optimization of our existing method. And this is the values which we have obtained in the capacity level performance result values. This is also CDF graph between RS, BS and also compare with omnidirectional. The omnidirectional also are placed at every SUs. Here RS graph from case 2s to 6s, also BS graph from case 2s to 6s. And this is the mean capacity resultant values for RS, BS and also omni result by varying the iteration index. And this is the CDF graph for RS, BS with the case 2s and also 6s. In this we have used APSS and also FPSS response. And this is the graph for CDF response for various capacity level. And this is the total capacity result by varying the number of SUs. Here also we perform the total capacity resultant value for RS, BS and also omnidirectional antenna. And this is the mean capacity by varying the beam width between RS and also BS algorithm. Here the maximum capacity obtained at 60° beam width level. And so far we have estimated the capacity level by various method. Here we perform both joint subcarrier allocation and also alternate state allocation process. Thank you.